They range from the global giants such as BAE, Boeing and Rolls-Royce, but we also work with a number of smaller companies as well. Businesses can either work with us as a partner, but you don't have to be a partner to work with us. So we do actually undertake one-off projects with companies who aren't actually within our partnership, or some companies join us as long-term members as well for that longer-term collaboration with us. So in terms of our core skills, the AMRC started in 2001 and its main core skill was actually machining. And that's how the whole thing started off. But since then, we've actually developed more core capabilities, such as integrated manufacturing, composites, casting, design and prototyping, structural testing, medical, additive manufacturing, metrology, virtual reality, and we also have nuclear in the form of the nuclear AMRC. So just about the AMRC Northwest. We were established in June 2018, where there was just two of us, James and myself. We're currently very kindly hosted in an interim facility by UCLan, who we work very closely with, and that location is actually on the UCLan campus, bang smack in the town centre. We like to say that we're actually an open access demonstrator, and we're actually demonstrating digital technologies. So from January 2020, we actually opened our doors for SMEs to come into the centre and view our technologies with a view to adopting them within their own setting. We're currently at 35 employees, but we will be scaling to around 40 to 43 from November 2020. So quite a steep growth curve from June 2018. As you can see, the picture of the building that you saw previously at the beginning, well, that's going to be our new home from August 2021. We've been working on the ground with a number of Lancashire SMEs since January 2019. And to date, we've actually delivered about 139 assists to Lancashire-based manufacturers. And we're also working very closely with Made Smarter. In terms of what we're actually doing here, there's no sort of point in duplicating everything that's done in Sheffield because it's only 2 hours down the road. So for example, we're not looking to do casting in the Northwest because we have one of the largest casting facilities in Europe based in Sheffield. So our key research themes currently are battery pack assembly, additive manufacturing, robotics and automation, machining, and all aspects of digitalization of manufacturing processes. So what's commonly known at the moment as Industry 4.0. We do recognise the fact that, within Lancashire and certainly the Northwest, industry and manufacturing does vary from what we've got in Sheffield. So, we do recognise that, our research themes will actually evolve to meet local needs. We're already seeing that, there's a lot of technical textile activity within the area. So, we're open to actually evolving to meet the need.
Okay, thanks for that, Melissa. So you've had a bit of an overview about what the AMRC group is and some of the background to why we're here in Lancashire and some of the rough areas. I'd just like to run through some of our current capabilities in terms of the specific research themes. So first up, we do quite a lot of additive manufacturing. It's been touched upon briefly in some of the introduction there, but you might be wondering why we chose additive manufacturing as one of our key areas of research. And it's because we see this having a very, very bright future in terms of displacing some traditional manufacturing techniques in certain applications. It gives you design freedom, it gives you part count reduction, it gives you options for lightweighting and reduction in non-recurring costs. So all in all, if it's applied in the correct way, it gives you lots of benefits, and we see this as a real technology game changer. So in terms of the different areas of additive manufacturing, we do quite a bit of work in both polymer and metallic systems. We have a range of kit that offers different capabilities in terms of materials, in terms of size, in terms of price point within the market. And this is typically applied in things like rapid prototyping, which is more your traditional application area for polymer additive manufacturing, or things like bespoke jigs and fixtures for production. So it offers lots of different options there, and we have a range of kit that can, in certain instances, replace traditional manufacturing concepts like injection molding, say, for low volumes. And again, it's coming back to this point that we'll probably keep reiterating throughout this afternoon session is understanding how to apply it in the correct way. This is not a one-size-fits-all solution to your problem, but in certain circumstances, it fits well. And we see our role as the AMRC is helping to industrialize this process, bring it through so industry can actually use it in their everyday operations. So beyond polymers, we do quite a bit in metallics, specifically in this case, powder metallics. Aircraft manufacturers and other manufacturers are looking to AM to solve some of the technical challenging problems they have in terms of lightweighting, as mentioned, part count reduction. And again, we have a range of cutting edge kit here in the Northwest. We've invested quite heavily in this area in terms of current state of the art system. So the system in the image there is a quad laser system. It allows us to apply the laser, 4 lasers simultaneously to really improve that production. So we say that price point. And one of the images I've got on the screen there is looking at something called the General Electric fuel nozzle. And again, this was a component where additive manufacturing really made sense because it gave part count reduction, it gave efficiency improvements through complex internal geometry, which just isn't achievable by any other means. And it was actually more robust, and it resulted in fuel savings. So again, this point that we'll keep reiterating, if it's applied in the right way, then it really makes sense. And as you can see from the list there, we have the full range of pre and post-processing equipment to really validate and verify the parts that we make and the assist that we give companies. So that's the very small detailed parts, sort of fit on your table size components. We're also looking heavily at, should we say, larger components that won't fit on your table or would make your table. And there's a couple of images there of some of the output of some of the technology solutions we either got or we're going to have very soon in terms of wire arc additive manufacturing. So again, this is a slightly different system of 3D printing where we actually feed a welding wire in rather than powder. And as you can see, you can build these very large near-net shaped components. It's an alternative to some traditional manufacturing routes where, say, for instance, a manufacturer might receive a forging and then machine it to its finished form. Obviously, some of the issues there are very long lead times, very high costs in terms of making the actual forging molds, forming processes, and this really gives you an alternative there in terms of reduction from, say, 18 months down to 3 months. It gives you options to reduce your build volumes from, say, dozens or hundreds down to single items, so you can bespoke and you can have a lot more control there. So we're investing in a couple of systems there to help industry look at this technology as a viable alternative. And the other image there is additive friction stir deposition. So this is a completely brand new system. We've got the first one in Europe that's just been delivered last week. And this is where you use a friction stir. It's a bit like plasticizing your material and then building up in layers. And the advantage of this technique is it doesn't get to the melting point of the material. So you don't have some of the issues with distortion because of the heat. You don't have issues with some of the complex microstructures of some of these materials. And you can put dissimilar materials together and you can have multi-material properties there. So all technologies that are promising but not industrialized yet. And that's where we see our key role in terms of bringing on these new technologies, maturing them and should we say, debugging them to the point where industry can actively use them. And as my old boss used to say, if there's no industry pull for any of this technology, it's just your hobby. And we're really keen to make the point today that we align ourselves with what industry needs, because otherwise it's just our hobby, and that's not what we're about. So As Melissa outlined, one of the core competencies of our main group is machining. We've been doing that for more than 20 years now. So it made sense to bring that into the region as well. There's a lot of industry in the area that uses machining technology, and we're investing in a number of multi-axis machine tools there to allow us to help SMEs with the latest and greatest techniques, but also supporting our near net shape activity. So the ability to machine to finish component, some of the additively built parts is crucial. Understanding how they respond from a traditional process is important. And again, it's bringing best practice into the region. And some of the examples of that best practice are things like, how do you select the correct cutting tools? What are the new developments in tools in terms of manufacturers' products out there? You know, how do we do offline modeling to minimize distortion or increase productivity? So we approach this in terms of, we're there to prove or disprove some of the sales spiel you might get from some of the manufacturers, and to give you give manufacturers an agnostic view of the world in terms of how do you make your product quicker, cheaper, greener, whatever your output that you're measuring is. How do we help you get to that point by the application of new technology? So it's very much what we're looking at as well. Obviously, we can't make things multiple times faster and new processes without actually verifying what we're doing. It's a key part of what we do, and it gives us credibility in terms of helping manufacturers with real world problems. So we've got a range of technology there looking at, you know, how do we measure and verify from multimeter componentry, you know, accurate geometries down to small micrometer defects within, say, an additive build or a machined component. So we've got quite a range of kit there that allows us to look at this. And an additional element of that, oh, my dog in the background, apologies. An additional element to that is understanding the function that reverse engineering can have, particularly with additive manufacturing. It allows us to look at the way components are made in an existing way, and maybe do a bespoke one-off via additive manufacture. As Melissa said, we're not duplicating what we're doing within the whole group within the Northwest region. One of the unique areas is battery electrification. Obviously, as we're all aware, electrification of transport is a key thing at the moment, low carbon initiatives. And it made sense to apply some of our flexible and intelligent automation techniques to the problem of making the battery packs for both automotive and aerospace. So we've got a range of kit there where we can look at things like joining techniques for electrical connections. There's obviously thousands of these within a pack, and they need to be very robust. So we're looking at new techniques around laser welding and heavy wire bonding of connections for alloys with high reflectivity and very thin sections. It's quite a challenge. And obviously we've got the testing kit there that we can look at individual cell level testing, performance testing, all the way up to module and pack level. So it's quite a unique capability within the region, and it's allowing us to look at different market segments and help other manufacturers. Obviously, there's quite a lot of talk about digital at the moment. Industry 4's quite topical. We have an array of themes where we help industry from, you know, very large projects. So we recently announced a 5G manufacturing testbed, all the way through to very small assists where we're helping manufacturers put sensors on legacy equipment, and everything in between, to be honest. So, you know, things like discrete event simulation, where we can simulate plant and factory layouts and the processes, AR, VR simulations of new products to allow people to visualize them within a realistic setting, and things like embedded sensors and human in the loop. So a range of technologies there that we can help companies with of all shapes and sizes, and you know, different points on the, should we say, the implementation ladder. So this is all well and good, you're saying, but what does this mean to Lancashire manufacturers? Well, At the moment, we are running an ERDF, European Regional Development Fund programme to assist SMEs within Lancashire on a range of topics that we've just discussed there. So additive manufacturing is a key one, and we're going to come on to a case study very soon where we're going to look at a real world example there, through to the simulation side of things, and things like CAD design, software selection, that kind of thing. So we've got a range of offers to the region. We're very much excited to be here, and very proud that we were supported to come into the region with some of the technology we're offering. So hopefully that's given you an overview and you found that interesting in terms of some of the areas we're looking at. I'd now like to hand over to Melissa, who's going to explain a little bit more about our SME program and how you might engage with that. And then we've got a short video just highlighting some of the other SME assists we've been doing. Stop.
So from our videos, you'll actually be able to see that the AMRC not only undertakes huge research projects for large companies, but we also work a lot with smaller SMEs. Since January 2019, we've actually assisted over 120 Lancashire SMEs through our fully funded ERDF programme. We've provided support in a diverse range of technologies, for example, additive manufacturing, digital transformation, virtual reality, discrete event simulation, robotics, automation, electrification, process improvement, and machining, just to name but a few of them. Our programme of fully funded ERDF assists for local manufacturers will actually continue till around June 2023, shortly after which the access to European business support funding unfortunately will cease for obvious reasons. Typically, we offer a minimum of 12 hours support in any of those research themes that we've just talked about. And currently the most popular areas seem to be additive manufacturing, machining, and digital transformation strategies. In order to access the SME Assist programme, you've got to be an SME, you've got to be based in Lancashire, you've got to have less than 250 employees and a turnover of less than 50 million euros. And to access the support, it's actually quite easy, quite simple. All we need you to do is fill in a business registration form just to prove that you actually are an SME. And then one of our engineers will contact you and scope out a project with you. And we'll produce a statement of works, which we need to agree with you, after which point we'll actually start working with you through the team and actually deliver the assist. To access the support, all you need to do really is go onto our website. We've got a page on the main AMRC website, and there's a form on there you can just fill in, and one of our team will get in touch with you. So quite easy, really.
Thank you for that, Melissa. Now we talked a bit about the technology. We talked a little bit about how you can get in touch. We'd like to show you a short video piece on one of the case studies that our additive team put together. So Dan, if you wouldn't mind teeing up the second video, please.
In the following video, we will be discussing the work that the AMRC Northwest has been doing with Raptor Titanium, a local manufacturing SME that we have been working with as part of our ERDF SME engagement programme. We will mainly be focusing on the laser powder bed fusion additive manufacturing technique to highlight the basic workflow steps that are involved.
During the AM design review with Raptor, it was clear there were some opportunities for laser powder bed with their products. So namely, they were lightweighting, consolidation of parts, lights out manufacturing, and customization. So customization in the form of for a rider's weight or feel. So here on the desk you can see some laser powder bed applications here, broadly split into families of parts. So you have a group of components that suit the medical sector, a group of high temperature applications, so processed with nickel alloys, some fluid transfer devices, so you can see elements of lightweighting in these also, and then some more specific lightweighting elements. Just to labour on this component a little bit, this is topologically optimised using software to remove material where it's not needed, thus minimising mass. And it's this approach that we've taken for the project with Raptor Titanium. There are many different types of AM technologies. Broadly speaking, they can be categorized into polymers and metallics, and then further broken down into feedstock, deposition, and the heat source that each machine uses to consolidate the material. What we have here is a laser powder bed fusion machine from Renishore. The significant differentiator between this machine and others on the market and some of the older Renishore equipment is the number of lasers. So this machine itself has 4 lasers on board to really up that productivity rate. With laser powder bed, we are limited to materials that are available in powdered form from an atomizer. So for us, typically that would be nickel alloys, titanium alloys, and aluminium alloys. Here at the AMRC, we're not limited specifically to the laser powder bed process. We have wire arc additive manufacturing capability. We have additive friction stir deposition technology from Meld Manufacturing in the US. And we also have another WAM capability coming from a company called Giefertech that will be due in the latter parts of 2021. There are a number of barriers to adoption for laser powder bed in industry. Namely, these would be productivity and therefore cost, qualification, and design. And it's the design element that's really been brought out in this project to really get the benefit out of laser powder bed by completely optimizing the design of the component.
My name's Chris Williams. I'm an engineer at AMRC Northwest. As part of our SME engagement with local engineering firms, we've been working with Raptor Titanium, a manufacturer of titanium off-road motorcycle foot pegs. They wanted us to do a study to see if we could redesign their foot peg design for the use with laser powder bed fusion technology. The approach to the design is to use topological optimization. That comes underneath the overarching banner of a generative design tool. So what we do is we take the geometry from an existing component and we just create quite a simple blocky model that shows them the overall design space. We then apply constraints and loads and the material to this model, and then we run the analysis. That will then produce us a stress plot which shows us where the energy is being forced through the volume. This then gives us the basis of our new laser powder bed design. Once you have the topological optimization study, there are a number of different approaches that you can take to develop the end geometry that will be used to build the part. For this component, I've chosen to use the study as a guide and then use standard design methods to create a geometry that will build for laser powder bed, so it is optimized for that technique. So what I've done is to block out the design. You can see it building up now around of this study using geometry that I know will work for the laser powder bed technique. So there's quite a lot of steps in the tree because the geometry is reasonably complicated. The end result is geometry that we know will work well for the machine of choice and has the minimum amount of support material but meets the prerequisite requirements of the customer for weight and strength, and ultimately must meet a price point.
So when we receive the CAD output from Chris, we're able to bring it into the build preparation software. It's here where we can orientate the part, we can assign any supports that we need to, we can instance the part for productivity, so we can populate the bed with these components, we can assign multiple lasers to the part, We can assign scan parameters to the part, so parameters associated with the laser, and we can export a build file ready to be built on the Renishaw laser powder bed machine. So the build preparation software is really quite intuitive, with a standardized workflow running from left to right. The first step is always to orientate the part. So you do this by selecting the downward surface, which flips the part to its chosen orientation. Secondly, we'll choose a material file. So this is a file which contains all the associated laser parameters and things that the build file will need. We can then move down and we can move the part around. If we stick it up in this top left corner, it gives us some room to be able to instance the part. By instancing, I mean making multiples of the part, so we can fill the whole build volume with components. And it's with the multi-laser machine, we're able to address each individual row of these of this build with individual lasers. So last of all, we'll go through the slicing and hatching portion of the build preparation. It's here where we slice a part up into 60 micron layers in this instance, and we assign all the laser parameters. You see in the top right corner the scroll bar, and we can use this to look through each and every layer, and we can zoom in and in detail look at each and every scan path. And then we can zoom out and we can use the feature here on the bottom, and we can look at the laser running from left to right, so from start to end of that layer, and we can see what the laser does at any one time. Further zooming in there, we can look and we can scroll through in detail and look at every single scan path. So when this operation is complete and we have each slice, we can send that build file over to the machine now. So the digital twin's quite a buzzword in manufacturing at the moment. With this process, we have the capability to look at the process itself in detail. There are 3 photosensitive diodes in the machine, one which looks at the laser power and 2 which look through the optical train at different wavelengths of laser light for the process. So it's here that we're able to zoom in and visualize what was happening at any given point at any given time throughout the build. I've already preloaded the volume file, which is the file that the process monitoring software requires. It's definitely worth saying at this point, this is still quite a manually intensive process, so you do have to scroll through each and every layer in order to see any defects. But if we just look at Z, so this is the process monitoring data in the Z plane. This is a cut plane through X, and this is a cut plane through Y. So we are able to look at it in really some detail. You can see here what I've managed to do is thresholded the data out. So you can see this Gaussian distribution of what are common data signals coming from the photosensitive diodes. We can actually threshold that out. And then what that leaves is a scan around the edge. So we would expect that these signals are different in laser powder bed to the scans in the middle. But what we can also identify are these erroneous signals here down the middle of this section of a part. And then further they are carried over into this part as well on this particular layer. So the state of art of this kind of software now means that we're able to track down a possible defect and the location within the part. It would then need further analysis, non-destructive techniques. X-ray CT would be a common one, and other methods in order to track down if this was indeed a defect or some other erroneous signal coming from the photosensitive diodes.
Well, hopefully that gave you a good overview of a real-world application of some of this technology and some of the process steps and the real in-depth knowledge you need to understand where it will work for you and where it won't work for you. unfortunately, we're not quite at the point where it's Star Trek world where we tell the computer we want a component, and out it pops the other side with some powder in at the other end. So it is developing. We do see a big market for this in terms of helping companies bring this through into their production processes. But unfortunately, it doesn't work magic at the moment. And one of the things of magic it doesn't do is produce the part for us in time for the video filming, unfortunately. So we'll save that for next time in terms of showing you what it actually looks like. So apologies for that, for everyone out there waiting to see what it actually looked like. As we've been quite video heavy on this seminar this afternoon, we'd like to end our overview section with another video, just to show you some of the breadth of engagement with SMEs we have throughout Lancashire and throughout the country. So for the final video, Dan, please could you cue up video 3? Okay, well, hopefully you found that interesting. That's it for our overview part of the session today. We're now going to move over to the panel section where it's your opportunity to ask the panel here whatever questions you'd like about well, as long as they're answerable, about the technologies you've seen, about the regional assists, about anything to do with what you've seen today. So if you want to type your questions in the Q&A box, we'd be happy to try and answer them. So please, I encourage you to do so. We do have a couple of questions already, so shall I try Alan? This is all nonsense, it's all too expensive, and where can I find the staff in the local area? It's unrealistic. Okay, and that's a good start. Ian, would you like to try and answer that one?
Yes, of course. I'm just recovering from seeing myself on screen there for a while, so I was trying to close my eyes, but unfortunately it's right there. It's the demonstration there on the video is a very high-end stuff. So the machines there are circa £800,000, and you know, we're not saying for 1 minute that different SMEs are going to be able to adopt this kind of technology, but what we showed there, certainly with the Raptor case study, is that they're not looking at, you know, employing the technology in-house yet, but what they do have is IP in the design, and they have already their market share as well. So it's utilizing ourselves that we can point these people in the direction of our partners that can manufacture for them, that have already made these investments. So a lot of it does seem pie in the sky, certainly when you talk about one-click design and that kind of stuff, but it's happening now. There are different barriers of entry for different businesses in different sectors. And I think, James, as you alluded to earlier, we're very agnostic to machine provider and technology. If it's something that indeed isn't for an organization, then we will be very upfront and honest at the start and say so. It's for us to industrialize the technology and find out these applications. We certainly won't be taking people down blind alleys with us. So
okay, thanks for that, Ian. Another question here from David. I like the look of the topological software. What are you using, and how do you get access to it? So I'll direct this one at Chris, please.
Yeah, for the demo, we've used NX from Siemens, but that's not to say it's the only piece of software in the market, because it definitely isn't. Nearly every single CAD vendor now has a topological optimization bolt-on or thread within the software. So, you know, if it's SolidWorks, there's an option there, Fusion 360, Solid Edge, that they can all do the same types of things. They do all have their own kind of take on how they do it. So depending on where the software is derived from, so if it was an MSC product with Apex, then it's going to come at it from an FEA heavy perspective, which is brilliant for the environments that's working within. If it's coming from a more design environment, you know, or maybe something more affordable like Fusion to get on the ladder very quickly, there's something out there for everybody. It's just finding what works for you, your products, your company, and we could help you to guide you with that, because we do have access to not just NX, but several different packages.
Okay, thanks for that, Chris. Final question, it would seem, unless anyone's got any extra ones. So this is from Beth. It wants to know which other organisations within the region are we engaging with? Could we give a bit of an overview of that? So that sounds like a question for Melissa, if you wouldn't mind, please, Melissa.
Okay. We've currently got relationships with all of the Lancashire universities, namely UCLan, Lancaster and Edge Hill. We work with the colleges as well, and all the business support organisations, for example, Boost, the local chambers. We're working also with other ERDF contract holders in the region as well, in terms of kind of referring and supporting businesses. Just like to say also, companies have asked us how many ERDF assists they can actually undertake with us. From March 2020, we'll actually have another ERDF programme up and running. So 2 programmes will run simultaneously. So whilst the scope of our second programme is slightly different, an SME is actually able to have an assist under each programme. So if we've got SMEs out there who we've actually already assisted, they can actually come in for a second assist as well. And they have to be discrete projects, but you know, can be along the similar lines.
Okay, thanks for that, Melissa. We have a question here from Stefan. Would AMRC work as a bureau if we simply wanted to print some parts? So, Ian, would you like to take that one?
We're not geared up to operate in a bureau scenario for different reasons, some of which I won't say because I've got both my bosses on the panel. No, but we're not geared up to produce parts on any scale, really. What we would do is walk alongside you. We'd produce the demonstration parts at cost, and then we'd look at one of our partners that are within the UK supply chain for AM. So it's very much a focus for us is to grow the AM supply chain. We're quite behind the people in Europe. Certainly Italy has a very vibrant supply chain for metallic AM parts, and the UK is falling somewhat behind. So we wouldn't want to step on the toes of that within the UK, and we would work with you and our partners to do that. So we would take a nice package and we would hand that over to a partner to do the ongoing production for you.
Okay, thank you for that, Ian. Are there any other questions from the participants? No? At this point, I'd like to point you to a link that was going to appear in the chat, so you can give some feedback on today's session and the innovation festival itself. Dan will be putting that in the chat any moment, no doubt. And if there's no other questions, I'd like to thank you all this afternoon for joining us. Hopefully you found something of interest within the overview that we've given and some of the Q&A we've had at the end here. I'd like to thank the panelists for agreeing to be both filmed and take part in this afternoon's session. I know people don't like listening to themselves back on film, so thank you very much to everyone for that. And just to say thank you very much for having us this afternoon, and we look forward to joining the festival next year. So thank you all very much.
Thanks everyone. Have a great afternoon.
And thank you. Thanks, James. Thanks, Ian, Melissa and Chris. The AMRC is incredibly important to the future of the county and our innovation ambitions. And it's a real great opportunity. It's been a great opportunity to find out more about exactly what it offers and how that feeds into the wider region strategy. So thanks everybody for tuning in, and I hope it's helped answer a lot of your questions. And we'll look forward to seeing you on some more of the talks we have. But after that, thanks very much for joining us. Goodbye for now. There's no panelists left. There's no audience left now. I've keep them all out. So.
Oh, was that now?